Hello, everybody. My name is Clara Nichols. I'm an agronomist from Colombia, and I'm a permanent lecturer at the University of California at Berkeley. I'm also the co-director of the Latin American Center for Aroecological Research, CELIA, and also the coordinator of the Ibero-American Network of Agroecology and Climate Change Resiliency. And first of all, I wanted to thank Professor Stephen McGree and the whole FITS group at RIHN for the kind invitation to this symposium. Today, I want to talk about designing biodiverse and resilient farming system and all the experiences that we have in our group in Latin America. Diverse, severe, and location-specific impacts of an agricultural production are anticipated with climate change. So food production should increase substantially by using the same arable land base with less oil, less water, and nitrogen, and in climate change scenario, but also under social unrest, financial crisis, and pandemics. We think that this challenge cannot be addressed with the existing industrial agricultural model and its biotechnological derivations. And there is enough scientific evidence that showed how human activities are causing changes in climate. The last IPCC report indicates that the rise of CO2 and associated greenhouse gases could lead to the 1.4 to 5.8 increase in global temperature with a subsequent consequence in precipitation, frequency, and the amounts. And this is the reason why we have severe droughts, extreme precipitation events, heat waves, etc. And tackling climate change will require a strain in the resiliency. And we think that a resilient agroecosystem will be able to produce food even after suffering events of drought or storm, or also increase in oil prices or storage of external inputs. Among many traditional rural communities, farmers seem to face the situation despite the fluctuation in climate. Many farmers adapt, even prepare for climate change, minimizing productivity losses to the use of the agroecological practices. So the millennium indigenous knowledge that have nurtured traditional agroecosystem and has endured over the centuries is the strategic starting point for the agroecological design. So why traditional farming systems are important? Because they offer a wide range of management options and designs that increase functional biodiversity in the fields and therefore strengthen the resiliency of the agroecosystems. One example that I wanted to share with you are the guaruguarus in the corridor Cusco-Puno in Peru. These are millenary systems that have stood the climate change. For example, so these are raised beds surrounding with water that in the middle of frost, they can overcome the problem because the water absorbs the heat during the day, releases at night, and it's possible to have crops in the middle of frost. I'm discussing these guaruguarus because they are important elements of resiliency, and they can show other farmers how to do it, especially in these high altitudes where the guaruguarus are placed. They are about 3,500 meters above sea level. And the other systems that are very traditional, especially in different areas here in Colombia, are the azotea system in the Pacific region of Colombia, where we have a lot of precipitation. The average precipitation regime is 8,000 millimeters of water a year. So the Afro-Colombian women are decided to design a system that they can overcome this problem. And this is what the ingenious idea of these azoteas that are raised bed at the level of the waist of the women, and they can grow different kind of crops in this system, avoiding the problem of these floods that are in the region. And in another region in Latin America that have suffered a lot of drought is in the south of Ecuador, in Loja, where the farmers, this is a region where we have at least 200 millimeters of water a year by rains just in 2 months. And the rest of the year, they have suffering because of these droughts. But the way how farmers are overcome this problem is they using the rivers to grow crops. But the way how they are raising their or using this is with these raised little mountains where they have the crops, and they avoid all the problems of the water, and they use this by capillarity. And because they know that the river is going to dry, they start using this system where they make a huge hole where they add a lot of organic matter, and they can grow these crops in the middle of droughts. But it is very important to realize that it's not just the innovation of farmers, what they have been demonstrated that is important, but also several practices like the increase of organic matter and water storage in the soil. And it's very important to admit that with an increase of 1% of organic matter, the soil can storage an additional 16.7 liters of water per square meter. This is equivalent to 167,000 liters per hectare. So it's very important to add organic matter in order to storage water in the soil. But also this is associated with another practice that is very common on agroecological farms, is the use the biology in the soil. And what is the difference between not having or having mycorrhizals? Mycorrhizal is a fungus. It's a fungus that have association with the roots, very important. And a plant in 1 liter container can have 1 kilometer of mycorrhiza. So the radical hair absorb nutrients within 2 millimeters. When they have mycorrhiza, these IFAs can scan up to 80 millimeters. It means 40 times more exploration of these filaments. So this network extracts nutrients from spaces to which the roots do not have access. And they maintain that kind of resilience to the system, especially with these critical drought events. And the other aspect that farmers are doing in Latin America, that practice that is very important, is even if they are in a semi-arid region, is collect the water when it rains. Because in these semi-arid regions, rains in 2 months. So harvesting water at farm level is so important in different places in Latin America. And at the same time, the different strategies, how they grow their crops, are so important. So when they are using polyculture, are more resilient to climate change. Why? Because this polyculture exhibits greater stability in yields and lower production declines than the monoculture under different climatic conditions. Data from 94 experiments with, for example, with various sorghum association with guandul, that is a legume, showed that for a particular extreme event, the guandul monoculture will fail 1 by 5. The sorghum will fail once in 8. But when we have polyculture, they fail 1 in 36. So it's very important to use polyculture to avoid the problems in climatic events. The same with agroforestry systems. For example, when coffee and cocoa are growing in agroforestry system and they have shade levels of 40 to 60%, they create a microclimatic condition that protect the crops from the high temperature fluctuation and also from low rainfall by reducing soil evaporation. So in the example of coffee, you can see in this slide how when we have a high diversity shade, we have less evaporation than when we have a very simple shade or low shade in the agroforestry system. So we need to avoid the evapotranspiration using these designs. And in this example of coffee, you can perceive clearly how we can reduce the ecosystem services when we reduce the diversity, and also we reduce the climate resiliency. So in this monoculture, coffee monoculture, we can have higher yields, but this system require more external inputs and they are very vulnerable to climatic events. And most of the farmers in Latin America are using local genetic diversity as a key to climate change adaptation because they have more potential even when they are using agroecological practices. And this is an example from Chiloé Island in the south of Chile, where the women, the Chilota Indian women, are kept more than 450 varieties of potatoes that are very tolerant to droughts. And they have been selected more than 6 different varieties that are very important to share with the Ladino farmers because they are very drought tolerant. And the same example coming from Mexico is this community of that have an NGO in Oaxaca, in Mixteca Alta, where this center, SEDICAM, Peasant Integral Development Center, that they received the Goldman Award for the reforestation, soil conservation, and sustainable agriculture practice that they are doing in the region, and also the project of agroecological restoration. So in this particular region, they have suffering of severe droughts. It rains only 300 millimeters a year. But Mexico is a center of origin of corn, and you can see that they have varieties that can grow in different altitude regimes, but also different precipitation regimes. And they had the fortune to have maíz de cajete in this particular community, where this maíz de cajete had been one of the main innovations that they are part of the resiliency of this community. And what they are doing is planting this maize that are very tolerant, drought tolerant, but it's not only the variety, but also the practice how they plant this variety. They open a hole with 20 centimeters deep, and they add a lot of organic matter. And this is the only corn that is growing during the drought season. And it is important to realize that, for example, in this table by Bandana Chiva demonstrated that native varieties, even that they produce less, or in terms of yield, the yield are less than the bullet variety. And I think it's important when we compare modern varieties and with native varieties to see other indicators. For example, what is the demand of water? In this particular table, you can see that the native varieties are more, demand less water than the bullet varieties or the modern varieties. And the same with the fertilizer demand. But the most important indicator that we need to evaluate is the productivity with respect to the water use, kilogram per hectare per centimeter of water. And you can see that native varieties produce more, the productivity is higher per centimeter of water than the bullet varieties. It's twice the productivity. So I think it's very important to select the right indicator that demonstrate that the native varieties are more resilient to climate change than modern varieties. And this slide summarizes what we are doing in agroecology. We know that we have different climatic events, and we are looking for the resilience of the agroecosystem, and we are focusing this resilience in three different pillars: in vegetational diversity, the complexity of the landscape diversity, and the conservation of soil and water. And for these three pillars, we can use different practices, as I wanted to show several examples by using agroforestry system, polyculture, genetic diversity, silvopastoral system. And in order to conserve soil and water, we can add a lot of organic matter. We need to cover the soil. We need to harvest the water. And we have several evidence. The first evidence that I wanted to share with you is when the Hurricane Mitch hit Central America. And Professor Ericol Jimenez had the opportunity to evaluate the conventional farms and the agroecological farms. And the idea was to see different practices that the agroecological farms were using, like mulch, living barriers, dead barriers, terraces. And he observed that the agroecological farm resisted more the impact of the hurricane than the conventional farms. And in this slide, you can see how the mudslides in this particular, you can see the mudslides post-Mitch in conventional farms were higher than the agroecological farms. And the idea with resilience is how fast they can recover. And with this particular evidence in Cuba, this is our second evidence in Cuba, the work by Fernandito Funes and collaborators in Cuba demonstrated that systems that have high diversity like these ones and areas under industrial monoculture suffer more damage than the agroecological ones. And you can see that even the percentage of damage was very high. The mean was 70%. But the most important thing is after the hurricane, that they lost many things, but the productive recovery was about 80 to 90% in those farms that have high diversity. So the resilience is the capacity of recovery fast when you have high diversity. And the third evidence that I wanted to share with you are the silvopastoral systems here in Colombia with the work by CIPAF, Enrique Murgueito, and Redagres. And when we talk about silvopastoral systems or agroforestry arrangement that combine forage plants such as pasture and legumes with trees and shrubs for animal nutrition and complementary uses. And this silvopastoral system have demonstrated they have more resilience than the pure monocultures of pasture. This is in the same region in the Caribbean of Colombia, and you can see that in this particular monoculture we have 2 or 3 centigrades Celsius of more temperature than in the silvopastoral system that are in the same region. But in this particular system, we have less evapotranspiration and high relative humidity and better comfort for the animals. So I think this is very important when we talk about resiliency. And these intensive silvopastoral system using Leucaena leucocephala are here in Colombia and have demonstrated that despite the fact that we have a lot of precipitation or less precipitation with the Niño phenomenon or the Niña phenomenon, and the production of milk remain constant. So more or less they produce 10 liters per cow per day, despite the fact that we have certain years that we have less precipitation or more precipitation. And the last evidence that I wanted to share with you is in Cuba with La Finca del Medio. And this is our picture before when they started the farm 10 years ago and compare with how the farm looks like today. And This is the assessment of the socio-ecological resilience of this farm. And you can see that we evaluate different kind of indicators, but we did a retrospective evaluation in the first phase from 95 to 2000. And it was moderately resilient with low diversity, and also using certain kind of conventional inputs. And then with the transition from 2001 to 2005, and this socio-ecological resilient index was 75%, compared with the third phase from 2006 to 2015, when we have a lot of agroecological designs, and we achieve this socio-ecological resilient index arrived to 99%. You can see the different indicators, how they grow after the years. And the idea was to close all the cycles in the system. So try to harvest the water, add a lot of organic matter, traditional varieties, animal integration, and so on. So diversify agricultural system using different strategies, polyculture, agroforestry system, used by small farmers. We observed that they achieve greater yield stability, greater resilience, and to climate change. And it is important to realize in this kind of symposium that we need to look for the kind of path that we wanted to take. Shall we want to take the path of conventional agriculture, with they are looking for the homogenization, the agro-industrial productive system, where we reduce the biodiversity, the stability, and resiliency, or we move towards a pest and agricultural system where the main strength is the diversification with agroecological networks, and with the idea to have the principal idea is to sell to the high value added products and services, to have a lot of ecosystem services, but to increase the biodiversity, the stability, and the resiliency. These are the properties of the resilient agroecological designs that I wanted to summarize for this talk. First of all, the conservation of productive and functional biodiversity of farm and the territory, socially self-organized by forming self-help groups based on the needs and aspiration, because it's very important to share the successful farms through campesino, and to support each other in order to overcome the problem. So we need people who anticipate changes, high level of cooperation and exchange through these networks, honor legacy, and build this human capital to mobilize resources through social innovations. And I really appreciate this time. Thank you very much, and I will be very happy to answer some questions.